Good morning, Tahmeenakhan is here in TKMaths is fun. In today's video, we will see three forms of complex number and how to change one form into the other form. So all of us know that complex number is written as z is equals to a plus iota b, right? Which is written here. Now this form is called Cartesian form. You can write x plus iota y, you can write a plus iota b, where a or x is a real number. Iota b, this whole term, is an imaginary number. But don't forget that a itself and b itself are real numbers. What do I mean by this? We write like this, right? So this 3 is a real number, 2 is a real number. But 2 iota is an imaginary term and 3 is a real term. So remember this thing. This form is called Cartesian form. Then it is modulus argument form. Modulus argument form is written as z equals to r cos theta plus iota sine theta. We will see the connection between them in a while. The third form is called exponential form. Z is equals to r e power iota theta. We are not going into who discovered this thing. We are just studying right now what are the three forms and how to convert one form into the other form. Okay, now first of all you need to know that modulus of z means when we write it like this, modulus symbol z is equals to r. This means the size of the, for example, here I am representing this complex number with this line, right? Let me use some other color which is prominent here, right? So the size of this line will be called r or modulus of z. Now this point is suppose x comma y, or if I write here, for example, 2 comma 5, right? 2 comma 5, the point, where in the complex number I will write it as 2 plus 5 iota, right? Okay, so this will be your 2 and this will be your 5. So if you want to find out modulus of z, what will you do? You will apply Pythagoras theorem. So it will become 2 square plus 5 square is equals to 25 plus 4 is 29. So modulus of z or r will be equals to root 29, right? Then what is argument of z? Because you see in the modulus argument form you have theta, in the exponential form you have theta. So how do you get this theta? Theta is basically tan inverse y over x. You can see in the diagram. So it depends in which quadrant you have a complex number. We will see that also. Right now we are in the first quadrant. So it is always made with the x-axis. So we will measure this angle, okay? I will see later in the example if it is in the second or third quadrant, then how we will handle it. So at the moment it will be what? Theta equals to tan inverse 5 upon 2, and you will figure it out in radian because the angle theta is given in radian, which is between minus pi and pi. It is also called principal angle. For detailed videos, other videos of past paper question, you can see the link and you can click that. Right now here I am just giving a brief description of or quick recap of the concepts. Now we know one thing. You see I have highlighted the modulus argument form here and the exponential form. These forms are basically polar forms because they use polar coordinate. What are polar coordinates? R and theta. And Cartesian form uses Cartesian coordinates which are x comma y, right? So now let's see one example. Let me take minus here so that I can explain what is the meaning of it, because in the first quadrant we have already seen here. For example, we have to change this Cartesian form. This is a Cartesian form. I have to change it into modulus argument form and I have to change it into exponential form. Okay, so forms you must remember, it is z equals to r cos theta plus iota sine theta, and here it is z equals to r e power iota theta. So the whole thing is to find out r and theta and then plug in the values here. So let's see in the Cartesian form what does it mean. In the Cartesian form, if you see, minus 1 is somewhere here and plus iota, because this is imaginary axis and this is real axis, iota mean 1i, so it will be somewhere here. So the point is here, so this is your Argand diagram. So sorry, not the whole thing, just till here actually. I should not extend it. Give me a second. Okay, now perfect. Okay, so now if I want to see the size of this, I can apply Pythagoras theorem here. This is 1 and this is 1. So this is R, or this is called modulus of C. So R is equals to root of 1 square plus 1 square, which is root 2. So I got my R, which is root 2 for here also. Now I have to find out theta. Okay. I'm just leaving this space for theta. Now this is not the theta, right? Theta is actually this. So if I will find out this angle, I will subtract it from pi. Whenever you have angle in the first and second quadrant, you measure angle like this and it is plus. If you have angle in the third and fourth quadrant, you measure it like this clockwise and it is negative. So right now let me find out, sorry, let me use this color. Let me find out this angle. Let me call it A or whatever. Okay, so it will be tan inverse 1 over 1. Why? You remember SOHCAHTOA? For this angle, it is opposite over, which is 1. Adjacent, opposite over adjacent, which is 1 over 1. And if you use calculator, it will give you pi over 4. So this angle is pi minus pi over 4. So which is equals to 3 pi by 4. So my theta is 3 pi by 4. So I have converted the exponential form into modulus argument form and, sorry, Cartesian form into modulus argument form and exponential form. I hope you understood this, and we can do vice versa. You can see more videos on the link to get the experience of more past paper questions. Thank you very much. Take care.